Hi, Professor Bob Young back at you here. This is College Trigonometry, the series video number 4. And the objectives for this video, we're going to go outside the first quadrant and use definitions of trigonometric functions of any angle. Now, in the last video, we were using acute angles and staying within the first quadrant. So here, we're going to go outside of that realm. And we're going to use signs of the trigonometric functions. Watching those signs, those students get in trouble here if you're not careful. We're going to look at what's called reference angles and define those, and we're going to use those to evaluate trigonometric functions. All right, so we want to go ahead and look at the definitions of trigonometric functions of any angle. So we'll let theta be any angle in standard position here, and let some point P equal the ordered pair xy be on the terminal side of theta here. And we're going to call this terminal side R. So if R equals the square root of x squared plus y squared, because remember, this is the Pythagorean theorem for right triangles, x squared plus y squared is r squared. So solving for R, taking the square root of both sides, you're going to get the distance from that point, the origin 0, 0 to xy. We're going to define the 6 trigonometric functions of theta by the following ratios. So the sine of theta is going to equal y over r. And if you think about the last video, we said sine was opposite over hypotenuse. So this might even kind of follow those guidelines. Cosine x over r, maybe adjacent over hypotenuse. Tangent y over x, opposite over adjacent. And of course, if we have the big three here, we've got the reciprocal, cosecant, secant, and cotangent. Now notice on some of these, of course, the denominator of none of these fractions can ever be 0, or we'll have an undefined fraction. All right, we'll take an example evaluating trigonometric functions, and we're going to let the point P be down here in the fourth quadrant, 1, -3. So what I like to tell students to do is draw your triangle, let x be 1, y is -3. So to find r here, we're going to say r equals the square root of x squared plus y squared, plug in the x's and y's, and we will find r is the square root of 10. All right, so going back here again, we can say that the sine of theta is going to be y over r here, and that's going to be -3 over the square root of 10. Now, before you go ahead and rationalize as the example did here, I would go ahead and jot this down for the secant, or I'm sorry, the cosecant of theta, because when you take the reciprocal of sine, that's cosecant. You can just go ahead and reverse that right now. Here's the secant one down here. That will, if you take the reciprocal of cosine, will get you the square root of 10, and then rationalize. I always like to do that as I'm looking at these. All right, and continuing here, the tangent of theta is going to be y over x, which would be -3 over 1. Again, watching those signs will reduce to -3. And then just go ahead and take the reciprocal, as we said on the last slide there, to get the other ones here. Now, if you take the reciprocal of -3, of course, the cotangent here, you'll get the -1/3. So there's our first example of evaluating the trigonometric functions. All right, in our next example here, we're going to evaluate, if possible, the cosine function and the cosecant function at the following quadrant angle here. So what if someone gives you theta equals 0 degrees or 0 radians here, and P is the point 1, 0 here? Of course, this means x is 1 and y is 0. The cosine of theta would be x over r, which would be x is 1, and then, of course, r would be 1 here, following that similar suit, so you'd get 1. The cosecant of that, though, of theta is y over r, so notice that you could not do that one there. You'd have 1 over 0. So the cosecant would be undefined. So at these quadrant angles, this is the only exception where you have to be a little bit careful on the trigonometric functions. All right, so let's go ahead and finish the rest of the functions here. Now, the sine of theta at this quadrant angle would be y over r, so that would be 0 over 1. So although the cosecant did not work, 1 over 0, 0 over 1 is 0. So just be careful here. Can't have division by 0, but when 0 is the top part of the fraction, you get 0. Now, the secant of theta, if the cosine is x over r is 1, the reciprocal of 1 is still going to be 1 here, so doesn't matter on that one. How about the tangent? Let's think about this one now. We're going to have on the tangent of theta y over x, so that would be 0 over 1, so we would get 0. The cotangent of theta would be x over y. Oh, there's that 0 in the denominator, young, and that one would be undefined as well. So the cotangent of theta and the cosecant of theta, when the angle is 0 degrees or 0 radians, is undefined. All right, just to make sure we have that concept, let's try one more of these at the quadrant angles. Evaluate, if possible, the cosine function and the cosecant function at the following quadrant angle of 90 degrees or pi over 2 radians. And notice here the terminal side of the angle is on the positive y-axis. We're at x equals 0, y equals 1 here. All right, so we're going to use that point. Notice the cosine x over r is 0 over 1 is 0. The cosecant y over r, 1 over 1 is 1. And we might as well do the rest as well. Let's stand by here real quick. All right, so watch out here. If the cosine of theta is 0, its reciprocal or kissing cousin, the secant of theta, is 1 over 0, which is going to be that undefined. I'll abbreviate that. Cosecant is 1, sine is 1. How about the tangent on this one? Let's look at this one. We have y over x, which would be the tangent 1 over 0. So here's another undefined creature. Whereas the reciprocal of 1 over 0, 0 over 1, would actually come out to be the number 0. So some good examples here, looking at the quadrant angles and using those trigonometric functions as well. Next, we want to look at the signs of the trigonometric functions in each quadrant. Now, in quadrant 1, all functions are going to be positive. So the sine would be positive, the y value, the cosine would be positive, the x value in quadrant 1, and of course the tangent being y over x would be positive as well. Now, in quadrant 2, the sine and the cosecant is positive. I just like to look at these three because if you know the signs of those, you know the signs of the reciprocal. So the sine in quadrant 2, y is positive. The cosine x is negative, which makes the tangent negative. All right. Quadrant 3, y and x are both negative in quadrant 3, but remember the tangent is sine divided by cosine, remembering our identities in prior lessons, and you get a positive tangent in quadrant 3. And quadrant 4, you have the sine is negative y, the cosine is positive, and the tangent is negative. Now, some of you are looking at my little saying up top here. A lot of teachers will say this that teach trig. All students take calculus. Young, what does that mean? All A is in the first quadrant. Everything is positive. Students, look what's positive in quadrant 2. The sine, take, tangent is positive in quadrant 3. And calculus, the cosine is positive in quadrant 4. So these are just telling you for each quadrant, 1, 2, 3, 4, which signs are positive. Just a little tricky thing I've learned down the line. Next up to bat, we are going to play the quadrant game. And a lot of instructors love to give these on test and so forth, so you know where you're at. Now it says here, if the sine of theta is equal or is less than 0 and the cosine of theta is less than 0, it says name the quadrant in which that angle lies. Now, when you think about this, if the sine of theta is 0, I kind of always equate sine with y, and that means less than 0s and negative. So it would either be down here in quadrant 3 or quadrant 4 where y is 0. But wait a minute. It also says the cosine must be less than 0, which to me, cosine kind of relates to x there. And if it's less than 0, it's negative. So therefore, our angle must lie in quadrant 3. So you'll see some more of these type problems in your homework, I'm sure. Let's take an example here. Given the tangent of theta is negative 1/3 and the cosine of theta is negative, find the sine of theta and the secant of theta. Now, when you think about it, if the cosine or the x is less than 0 or negative, we must be in quadrant 2 or 3. But since the tangent is negative, we have to be in quadrant 2. So always know where you're at. I always like to draw a picture when I do these in class. I'm going to draw one here for you. And remember, tangent is y over x. And if you're going to go ahead and label this so you get a negative 1/3 here, y over x, the x would have to be -3 and the y would have to be 1. So doing r equals the square root of x squared plus y squared using the Pythagorean theorem, we'll get the square root of 10. Now notice r is always going to be positive no matter which quadrant we go around into. The x and the y values change from quadrant to quadrant. So this is, again, where I've said many times students get in trouble. So to find the sine of theta, y over r here, we would have 1 over the square root of 10, which if you wanted to go ahead and put the cosecant down here real quick, we could just take this and flip it and say, well, that would be the square root of 10. Now, it only said in the example to give us these two, but we'll just go ahead and do them all, show off a little bit here. And on this one that says the cosecant of theta would be r over x, which would be the square root of 10 over -3. And you can write it with the negative in the bottom, out front, on the top here. It doesn't matter as long as you only use one negative. Now the cosine here, if we want to go ahead and flip that, would be -3 over the square root of 10, which we could rationalize into -3 times the square root of 10 over 10. And now that we know the tangent is negative 1/3, well, that last one here, the cotangent of theta, taking the reciprocal, that's a piece of cake. So lots of good examples evaluating the trigonometric functions here. Now, the definition of a reference angle, it says let theta be a non-acute angle in standard position that lies in a given quadrant. And we've got just about all the quadrants here. Now, non-acute means it must be outside of quadrant 1. Because if you chose an angle in quadrant 1, its reference angle would equal that angle. So we kind of leave quadrant 1 out here. So it says its reference angle is the positive acute angle theta prime. So note here on a reference angle, the reference angle theta prime has to be between 0 and 90 degrees or 0 and pi over 2 radians if you're talking radians. It has to be an acute angle. It's formed by the terminal side of theta, okay, very important, and the x-axis. Now, I didn't say the positive x-axis, I said the x-axis. So in other words, here's quadrant 2 here, here's theta, okay? This would be the reference angle between the x-axis and this terminal side of theta. So it gives you a little definition here. If theta's an angle that's in the second quadrant between 90 and 180 degrees, then the reference angle would be 180 degrees minus theta. Okay, and you could also think radians there very easily as well. Did you want to do the radian ones? Why not? This would be pi over 2 to pi. So the reference angle would be pi radians minus whatever the angle was in radians. All right, in quadrant 3, if it's between 180 and 270 or between pi and 3 pi over 2 to get the reference angle, you're just going to take the angle and subtract 180 from it, and we're going to do some examples with this in a second, or theta minus pi radians there. And in quadrant 4, between 270 and 360, which would be between 3 pi over 2 and 2 pi, you would subtract to get this reference angle here, 360 minus the theta, whatever's given here, or 2 pi minus theta. And I think this will become a little more apparent when we look at some examples here. So those are just the definitions of a reference angle. All right, so some examples of some finding reference angles here. Let's say theta equals 210 degrees. So we'll go ahead past 180, another 30 degrees here. So if theta is 210 degrees here, theta prime again is this angle formed by the x-axis and the terminal side of theta. It must be acute again. So to get it, 210 minus 180, I think y'all see that will give you positive 30 degrees. Example B, if theta is 7 pi over 4, so we'll go ahead and draw that angle. Hopefully we're getting accustomed to drawing some of these angles in standard position by this time in the course, getting a good feel for things. Then theta prime would be this angle right here. So it would be this acute angle between the x-axis and the terminal side of theta. So I think you can see if you went all the way around, it'd be 2 pi minus 7 pi over 4 would get you pi over 4 for that one. What, you want to go negative, Young? Sure. So we can go negative 90, 180, 270 would be all the way around 3 spots, and then 30 past that, let's back off 30 here, would be about right in here. So this would be 30 degrees here from negative 270. So this would be theta equals negative 240 degrees. I think y'all see that this angle here then, theta prime, now don't worry about the negative here or here, be careful, remember theta prime must always be an acute angle between 0 and 90 or 0 and pi over 2. So I think you're going to get 60 there, 60 and 30 will get you this 90. And then what if they just give you 3.6 radians now? Now remember, if you started around here, pi as a number would be 3.14. 3 pi over 2 as a number, if you took and divided 3 pi by 2, you'd get about 4.71. So where would 3.6 be? Well, I think it'd be kind of a little bit closer to 3.14. I mean, close enough for government work here. And we'll say this is theta. So notice to get theta prime here, this angle right in here we're looking for, they took this 3.6 and subtracted 3.14 or pi approximately and rounded it to 0.46 here. All right, so hopefully you'll be able to find some reference angles as you work some of these in your assignments. Continuing, we're going to be finding reference angles for angles, of course, greater than 360 degrees or 2 pi, or less than 360 degrees or negative 2 pi. We do positive or negative. Now, to do this, we're going to find a positive angle. We'll call it alpha in this case. I'm getting tired of theta. Less than 360 degrees or 2 pi that is coterminal with the given angle. We'll draw alpha in standard position, and then we can use the drawing to find the reference angle for the given angle. And again, that's the acute angle. You've heard this many times now, formed by the terminal side of alpha, and the x-axis will get you that reference angle. Examples of reference angles beyond our normal 360 degrees or 2 pi's. Example A here, theta is 665 degrees. So if we were to draw it, breaking it apart here, we would go around 360. So we'll go ahead and start here. That will give us 360 degrees. Now we have to keep going another 305 degrees, ladies and gentlemen. So let me keep going here. Here's another 90, 180, 270, now to 305 degrees here. I'm going to have to add another, let's say 35 degrees, and I'm going to go ahead and draw this angle here to get that 665 degree angle here. Okay. Now, to get theta prime here, notice what they said. They just took the 360 on the second pass and subtracted the 305 to get 55. So that is how you can keep doing it. So you can wrap these around if necessary. Let's try one in radians. Example B, 15 pi over 4. Now remember, radians, 1 pi over 4, 2. So if we went around, it would go all the way around to 2 pi. So that would be 8 pi over 4, if you think about 2 pi in terms of 4s here, plus another 7 pi over 4. Here we go. And we will end up stopping here. So if this is again theta, and they give us theta as 15 pi over 4, theta prime still going to be that acute angle between the x-axis and the terminal side of theta. So in this case, I think y'all would see it's pi over 4. All right, negative you ask, negative 11 pi over 3. Well, you could go and say negative 11 pi over 3 would be equal to negative 4 pi plus another pi over 3. So I'll go a negative 4 pi direction. Watch this. Here we go. Here's negative 2 pi. Now, before I get all the way around again to negative 4 pi, I'm going to back off pi over 3, and I'm going to stop right here. So what I did is I broke this down into negative 12 pi over 3 if I went all the way around to here, plus pi over 3. And you will see that that reference angle then would be pi over 3 radians. And there's more than one way to think about these as well. I always like to draw pictures and see where I'm at and then kind of look at that acute angle between the terminal side of theta and the x-axis. All right, so let's go ahead and see how reference angles can become our friends when we go to learn these very important unit circle angles. I am now going to go ahead and fill in this whole blank unit circle with everything we've talked about thus far. All right, starting with, let's do the quadrant angles. I always like to start here. These are the most important ones to get the rest of them. So we're going to say 0 degrees and 0 radians, and the point would be 1, 0. Okay, up top here, 90 degrees, pi over 2 radians, 0, 1. All right, over here we've got 180 degrees, pi, negative 1, 0. And on the bottom here, 270, 3 pi over 2, and that will be 0, negative 1. So if you cut 90 in half, then I can do, well, this would be 45 degrees. If you cut pi over 2 in half, you'll get pi over 4. And then you can go ahead in between each half here and just add 45 degrees or pi over 4 radians. Let's do 45 degrees first. 45, 90. Another 45 would get us 135. Use the quadrant angles always to count 180. And another 45 here would get us, what, 225, back to 270, 315 degrees. Now let's do the radian parts of these. 1 pi over 4. Let's count 4s, folks. 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4 reduces to 3 pi over 2. 7 pi over 4, back to 8 pi over 4, or 2 pi radians, and we can go ahead and put 360 degrees in there and show off. Now remember, on a 45, 45, 90 right triangle here, since this radius and all of these is 1 on a unit circle, we said that the x and y value was the square root of 2 over 2, square root of 2 over 2. So here is where reference angles help you. All you have to do is go around the quadrants and change signs now. So this would be, x would change sign here, y would stay the same. Down here in the third quadrant, they both change sign. So if you get that first quadrant one and you know your reference angles, you have them all. So very nicely here we can do this. Now we also split our triangles into sixes or 30 degrees here. So we divided each quadrant by 30 here. So we got 30, 60, 90. So we can count by 30s around and get the degrees now. So keep adding 30, 120 and 30, 150. The quadrant angles always count 180 plus 30, 210 plus 30 plus 30. Plus 30, I'm trying to make sure I hit my degree thingies here, plus 30, back around 360. Now let's count by sixes now, all right? Remember 30 degrees, if you're not sure, you can multiply by pi over 180. You can convert degrees to radians, as we said. 1 pi over 6, y'all ready? 2 pi over 6 reduces pi over 3. 3 pi over 6, always use the quadrant angles. 4 pi over 6 reduces. 5 pi over 6. 6 pi over 6 is pi. 7 pi over 6. 8 pi over 6 reduces to 4 pi over 3. 9 pi over 6 is 3 pi over 2. 10 pi over 6 reduces to 5 pi over 3. 11 pi over 6, and then back to 12 pi over 6, or 2 pi radians. Now on a 30, 60, 90 right triangle here in the first quadrant, and you can kind of look at the y value here and say, well, that it would be half of this 1 here. If this were 1, a lot of students look over here and say, well, just remember they get these two values right. And then the other side of that 30, 60, 90 is always the square root of 3 over 2 times the smaller side. So if you, again, here's where those reference angles help. The square root of 3 over 2, 1/2. You can now go ahead and reverse it here for 60 degrees. And if you know these two, just change the signs the rest of the way. Watch this. So x changes sign in the second quadrant. So notice this x and y, these are reference angles here. They're the same distance down. Over here, these are reference angles as well. Just change the x value, and you can just easily coast to getting these very familiar angles here. Now, what's reference angle is this one with here? You might match it up with this one here. You could match it up with this one here. The signs both just change here. Negative square root of 3 over 2, negative 1/2. And then just flip them. You can match these two up, except that x becomes positive here, y stays negative. So the ones that are reference angles are going to be equidistant here. And ladies and gentlemen, there is the unit circle. Reference angles, extremely helpful. So use those to your advantage. Learn this unit circle, the circle of life, and all will be good in your trigonometric adventures.